Hello everyone, welcome to CodeWeb India. So in today's video, I'll try to explain how to solve this Leetcode problem, Univalued binary tree. So we're given a binary tree and we need to check if it is univalued or not. So a univalued binary tree is actually a binary tree in which the value of every node is equal, right? So in this first example, you can see that the value of every node is 1. So this particular case, we have a univalued binary tree, so we return true, right? But in this particular tree, a binary tree, we can see that the value of all the nodes are not equal. Do have a 5 here, so this is not a univalued binary tree, so we return false. So how should we approach this problem? An easier or intuitive approach is basically that you can traverse every element of this binary tree and compare the value. You would have done the same if this is an array, right? So let's just forget about the binary tree part for right now and consider that we're given an array and we need to check if all the elements of this array have same value or not. So my approach would have been to basically pick the first element and compare this first element to all the elements of the array and simply see that if we match an element that does not equal to this first element, we return false. Same would have been my choice for solving these kind of questions, or in this particular case, the binary tree. So I need to traverse every node of this binary tree and check if the value of that node is equal to the value of the root node. So in my previous video about the maximum depth of an array tree, I told you about two approaches, BFS and DFS. So BFS approach and DFS approach both can be used to solve this kind of problem. I find BFS much easier and it's iterative in nature. So I'll solve this problem through BFS. If you have any doubts regarding BFS, just visit that video and I hope it solved your doubt. So right now let's just see how to code this problem, and in order to code this problem I'll basically use the iterative approach and I'll solve this problem using BFS. So in order to BFS we make use of a queue that stores every node of this particular binary tree, and it basically extends the linked list interface, and that we insert the root node inside this queue and then we simply check whether this is empty or not, right? Then we calculate the size of this particular queue. I'll tell you in a moment why do we calculate this size, and for that size we basically pull out a node out of this queue using queue.pull, and then we check if node.left is not equals to null, we append the left child inside this queue using queue.offer. Not dot left. Same goes for the right child, and we append the right child and we return. So this is basically a sample template for a breadth first search iterative solution, but I told you we need to compare the roots value with every value of this particular binary tree, right? So let's just take the roots value as univalue. This is the root value, right? So we are getting every node here. So this node is basically every node of binary tree, right? So we can compare if node dot value is not equals to the univalue, which is basically the root value, we return and we do not do anything extra. We return false. Otherwise, if we are not able to find any nodes whose value is different for the root node, we simply at the end return true. So let's just run this code. Yeah, it is working fine for this particular case. It's just submitted. Yes, it is working fine, 0 millisecond, faster than 100%. So that's a very good thing actually. So I hope you like this answer. Thank you so much.